According to Article 430.24 of the National Electrical Code, it is not permitted to connect a branch circuit from one panel to another panel. Each panel must have its own separate source of power. Therefore, pulling a 12-2 run between panel A and panel B to share power would violate the National Electrical Code. While connecting the 12-3 runs to two furnaces on different panels may not cause any immediate electrical issues, it is not a recommended practice and could lead to problems in the future. Connecting the phases incorrectly, for example, a phase from panel A to B phase from panel B, could create an unbalanced load and power quality issues. Additionally, connecting the neutrals together could create a potential ground loop, which could lead to shock hazards or equipment damage. The issue of tenants sharing utilities is a contractual matter that should be addressed in the lease agreement. If tenant B does not want to pay for tenant A's heat, the lease should specify this and provide for separate metering or other arrangements. Based on the National Electrical Code and the laws of physics, it would not be code legal or safe to pull a 12-2 run between panel A and panel B to share power. Additionally, it is not a recommended practice to connect multiple furnaces to the same 12-3 home run from different panels. In this case, it was correct to opt for the safer and code-compliant solution of running a new home run from the main floor to the attic. When dealing with electrical systems, code compliance is paramount. The National Electrical Code, or NEC, provides guidelines to ensure safety and proper functionality. Article 430.24 specifically addresses the requirements for branch circuits and their connection to panels. This article states that each panel must have its own independent source of power, meaning you cannot create a branch circuit that spans across multiple panels. The reason for this is to maintain proper circuit protection and prevent potential hazards. When a branch circuit is connected to a single panel, the circuit breaker or fuse in that panel is designed to protect the wiring and equipment connected to that circuit. If a fault or overload occurs, the breaker will trip, disconnecting the power and preventing damage or injury. However, if a branch circuit is connected to multiple panels, the circuit protection becomes compromised. If a fault occurs on one part of the circuit, the breaker in the other panel may not trip, leading to potential overheating, fire, or electrical shock. In addition to code compliance, there are also practical reasons why connecting branch circuits across panels is not a good idea. Firstly, it can create confusion and difficulty in troubleshooting. When circuits are interconnected, it becomes harder to trace wiring and identify the source of problems. This can lead to increased downtime and higher maintenance costs. Secondly, connecting circuits across panels can create unbalanced loads. Electrical panels are designed to distribute power evenly across the different phases of the electrical system. If circuits are not properly balanced, it can lead to voltage imbalances and other power quality issues. This can affect the performance and lifespan of electrical equipment. Thirdly, connecting neutrals together from different panels can create a ground loop. A ground loop occurs when there are multiple paths for current to flow to ground. This can lead to unwanted current flow through the grounding system, causing noise, interference, and even electrical shock. Ground loops are particularly problematic in sensitive electronic equipment, as they can disrupt the operation of the equipment and cause data corruption. When dealing with tenant spaces and utility billing, it is important to have separate metering for each tenant. This ensures that each tenant is responsible for their own energy consumption and that there are no disputes over utility bills. If tenants are sharing utilities, it is often difficult to determine how much energy each tenant is using. This can lead to disagreements and resentment. In such cases, it is best to install separate meters for each tenant or to implement some other form of sub-metering. In addition to separate metering, it is also important to have clear lease agreements that specify how utilities will be paid for. The lease agreement should state whether utilities are included in the rent or whether tenants are responsible for paying their own utility bills. If tenants are responsible for paying their own utility bills, the lease agreement should specify how the bills will be calculated and how they will be allocated among the tenants. It is also important to have a process for resolving disputes over utility bills. This process should be fair and transparent and should provide a way for tenants to appeal disputed bills. In summary, connecting branch circuits across electrical panels is not code legal, safe, or practical. It is important to follow the National Electrical Code and to ensure that each panel has its own independent source of power. Separate metering and clear lease agreements are also essential for dealing with tenant spaces and utility billing. When working with electrical systems, safety should always be the top priority. If you are not qualified to work on electrical systems, it is best to hire a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not sure how to do something, ask for help. It is better to be safe than sorry. Also consider the different types of loads, such as inductive loads and resistive loads. An inductive load is an electrical load that primarily consumes reactive power, such as motors, transformers, and inductors. These loads store energy in a magnetic field. A resistive load is an electrical load that primarily consumes real power, such as incandescent light bulbs, heaters, and resistors. These loads convert electrical energy into heat or light. When sizing conductors and circuit breakers, it is important to consider the type of load. Inductive loads require larger conductors and circuit breakers than resistive loads because they draw a higher inrush current when they are first turned on. The inrush current can be several times the normal operating current. It is also important to consider the voltage drop in the conductors. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or fail. The National Electrical Code provides tables that can be used to calculate voltage drop. When installing electrical equipment, it is important to follow the manufacturer's instructions. The manufacturer's instructions will provide information on how to properly install and wire the equipment. It is also important to inspect the equipment for damage before installing it. If the equipment is damaged, do not install it. Contact the manufacturer for a replacement. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The grounding system should be properly installed and maintained. All electrical equipment should be properly grounded. Grounding electrodes, such as ground rods, should be installed in accordance with the National Electrical Code. The grounding electrode conductor should be properly sized and connected to the grounding electrode and the equipment grounding bus. Regular inspections and maintenance of electrical systems are essential for safety and reliability. Electrical systems should be inspected periodically by a qualified electrician. The electrician should inspect the wiring, circuit breakers, fuses, and other components of the system. Any damaged or worn component should be replaced. The electrical system should also be cleaned regularly to remove dust and dirt. Dust and dirt can accumulate on electrical components and cause them to overheat. Overheating can lead to equipment failure and fire. The National Electrical Code is updated every 3 years. It is important to stay up to date on the latest code requirements. The National Electrical Code can be purchased from the National Fire Protection Association. Many states and local jurisdictions also have their own electrical codes. These codes may be more restrictive than the National Electrical Code. It is important to comply with all applicable electrical codes. If you have any questions about electrical safety or code compliance, consult with a qualified electrician. They have the knowledge and experience to help you ensure that your electrical system is safe and code compliant.